Hi there, this is Electromagnetism Lesson 6. This is the generator effect and AC current generators. So we're going to establish what the generator effect is, link the generator effect to AC current generators, and explain how a bicycle generator operates. Alright, so first of all, the generator effect. So it's quite straightforward. If you move a current carrying conductor, or for example, a wire within a magnetic field, it'll produce, you'll get a voltage and you'll get a current. So if an electrical conductor cuts through a magnetic field lines, a voltage is induced across the ends of the conductor. If the wire is part of a complete circuit, a current is induced in the wire. If it's not a complete circuit, you'll still get a potential difference or a voltage across the conductor. However, it needs to be a complete circuit for a current to be induced. Another name for it, so we've got the generator effect. The other name is electromagnetic induction. And this is how we make electricity. So you can do the opposite. So if a magnet is moved into a coil of wire, a voltage is induced across the ends of the coil. If the direction of motion or the polarity of the magnet is reversed, then the direction of the induced voltage and the induced current are also reversed. So if you move a magnet into the coil, you might get a positive voltage and a positive current. When you pull the magnet out of the coil, you'll get a negative voltage and a negative current. So this type of power production actually produces alternating voltage and alternating current. So it deflects between positive and negative values. So the generator effect also occurs if the magnetic field is stationary and the coil is removed. Not removed, moved. So basically either the magnet can move or the coil can move. You still get the same effect. Okay, remember to pause at any point to make any notes. So the size of the induced voltage increases when? So how do we increase the voltage? So the speed of movement increases. So if you move the magnet or the coil at a quicker rate, you're going to get higher voltages, higher currents. Stronger magnets, so the strength of the magnetic field increases. Number of turns, so if you have more turns on your coil, again, you'll increase the voltage. And finally, if the area of the coil is greater, so if the coil's got a greater surface area, you'll cut more of the magnetic field, you'll get more voltage. And if there's a complete circuit, you'll get more current as well. Alternating current generators. So most electricity is produced using the generator effect or electromagnetic induction. The simplest generators and the types used in power stations will produce alternating current. So that's the current where it goes from positive to negative, positive to negative. Right, so here's an AC generator. So at the top, you'll see steady rate of rotation. So you've got to rotate this coil. If you rotate a coil inside a magnetic field, you'll produce an alternating voltage. And if there's a complete circuit, an alternating current. Now the steady rate of rotation, if you had one of these, you could just turn it around. Large scale in power production, it's, say coal, for example, coal, oil or natural gas. We take the coal, if I can speak properly, oil or natural gas, the fuel, we burn it, it gets really hot. We use it to heat water. The water will turn into a high pressure steam. The steam then turns a turbine, which is connected to the generator. In renewable energy sources such as, say, wind power, there's obviously no water involved. The wind will directly turn the turbine. The turbine's connected to an AC generator. So for wind, for example, the steady rate of rotation is the wind itself on the turbine, and it'll spin the coil inside the magnetic field, and we get an alternating voltage and coincidentally an alternating current. Hopefully that's okay. Let's move on. So the voltage against time graph might look like this. So, you get positive values, you'll get negative values. All right, let's move on. So it's like an electric motor in reverse. So as the coil is rotated, we get the electromagnetic induction or the generator effect. So you get an alternating voltage induced in the coil or across the coil. Alternating current is drawn off through the two slip rings at the bottom. Again, the faster the coil is rotated, the greater the amplitude of the voltage and current. You could just imagine that as you rotate it faster, you get more voltage and current. The amplitude thing we'll come on to in a moment with a question. And the higher the frequency. So frequency is obviously the amount of rotations per second. So if you spin it round faster, your frequency is going to go up. If you remember that mains electricity in the UK is supplied at 50 hertz, so that will be 50 full rotations per second between. So it goes to positive, all the way back to negative, back up to positive will be 1, and that happens 50 times a second. All right, let's move on. So what about bicycle generator? So just looking at this diagram, you could probably figure this out. So there's a wheel that's attached to the bicycle wheel. As you pedal, the small wheel will rotate, which has a rotating magnet attached to it. The magnet is next to a coil wrapped around an iron core. So we're going to get electromagnetic induction or the generator effect. This is normally connected to a light, so you can use the motion of the bike to produce electricity for the lamp to work. So just in writing, when the wheel turns, the magnet is made to rotate next to a fixed coil of wire. So you get electromagnetic induction occurs, and an alternating voltage is induced, across the coil. Because it's in a circuit, it'll cause an alternating current to flow to the light bulb of the bicycle, and your lights will light up. You could be asked that question. It could be a nice 4 marker. It could give you a diagram and just ask you to explain what's happening, or it might not give you it. It might just say, explain how a bicycle generator works, and this is the type of response that you would need to give. Keywords that definitely include, electromagnetic induction. All right, let's move on. So we've got a question here. You can have a go at this one if you want to pause. It's quite tricky. So it says the graph opposite shows how the voltage of a generator varies against time. Using the same set of axes, show how the voltage would vary if the rotational speed of the generator is doubled. So if you double the rotational speed, you've got to remember, what happens to voltage. So if you double the speed, everything's happening twice as fast, so you're going to get double the voltage. You're also going to get double the amount of rotations in a fixed period of time. So the graph would, the voltage would double, but you'd also end up with twice as many waves. So you'd end up with something like this. So the new voltage will have twice the amplitude and frequency. So frequency is obviously the number of cycles per second. So initially you've got, just draw this out, so we've got 1 rotation there. If it's going twice as fast, you're obviously going to get 2 waves in that space now, which you'll see when I flick it back on, and the voltage will also double, which is why the wave gets bigger amplitude and twice as many waves. So at that point where the original wave ended, just put a big circle there, you can see that there's now 2 complete waves in there, and that's just simply because it's being rotated twice as fast, so the frequency will obviously double as well. All right, let's finish with this. So you can either write this out to get some comprehensive notes, or 1 to 9, I think there's 9, yep, put the keywords in. So I'll leave it there for a second. If you want the keywords, I'm going to put them on. I'll put them on now. If not, obviously you need to pause. And then I'll take you through the answers. So the generator effect occurs when a conductor is moved relative to a magnetic field. This is known as electromagnetic induction. The greater the relative movement of the conductor and magnetic field, the greater is the voltage induced. If the conductor is part of a complete circuit, an electric current will flow. Alternating current, that should be a capital letter A. Alternating current is produced if the direction of movement is continually reversed. I didn't put that as a capital letter because it would have given away the location, but I'm pretty sure you've done well anyway. Right, that's it. Hopefully you found that helpful. Thanks for watching, and I'll speak to you soon.